So, why do we care about heat? Rapidly changing climate is known to be one of the biggest issues of nowadays society, of course, and this leads to temperatures rising, especially in summer, especially in the cities. However, we have noticed that even in the Nordics, even in the Scandinavian cities, we've recently recorded unseen before temperatures, and this has led us to being interested in heat. But some areas in the city tend to be safer than the others. Why so? These questions we're going to address in this presentation and in our project. So there is a certain safety that I mentioned, and the safer parts of the city are known to be linked to actually not just city geometry, but also greenery. And the greenery, like urban forests and smaller greener spaces, bring us to alleviation of heat events by shade and lower absorption levels by the green surfaces of heat than man-made structures. And to what extent can we actually mitigate the heat with the help of greenery? And what type of greenery is the most important in this question? To address this question, we, together with MIT, have developed a city scanner, which is a device that can measure ambient temperature, object temperature, air temperature, and humidity while on the move. So those devices, 5 of them to be more precise, have been deployed on BuzzSpot taxis, which you can see in the picture, and they have been driving around the city of Stockholm measuring radiant heat, which we were most interested in, as well as humidity, as they affect human health and perception of heat the most for humans that reside or travel through the areas. So the data that we've collected covers the most areas of the city of Stockholm with repetitive measurements in a number of places. To the left, we can see actually the device moving through Humlegården, which is a rather big park in the city, and we can see how the temperature gets lower because blue means it's colder. And to the right, we can see how the measurements are distributed, and they've been divided into 2 different driving directions as the city scanner measures to the right, and that's important for us to know what's exactly in the right. So given the GPS precision as well as the coverage of this opportunistic data, we have decided to use interpolation techniques to actually summarize the values. To quantify the impact of greenery on the city heat, we have gone to a conclusion that we need to take some analysis of different factors that can be affecting heat. Among these were buildings, land use, then sun exposure, as well as greenery itself. Visible greenery to the left, together with visible sky to the right, have been calculated using Google Street View imagery and later interpolated in order to create a continuous surface. Then we have decided to map our heat and compare it to 2 different techniques that have been used widely in temperature analysis. To the left, we can see comparison to the remote sensing data, and red means that our scanner is hotter measuring, and blue means that it's colder. And to the right, we can see comparison to the alleviate stations that are placed around the city, and they were measuring around the same time. As we can see, there is a certain trend that repeats itself in both pictures. Like, for example, Norrmälarstan tends to be hotter as measured by the city scanner, and it is close to water, which is quite important because if water cannot mitigate the heat, then we need to find out why. But there was a number of issues that has led us to developing a new model, an improved model of the city scanner. As for example, we couldn't find out what exactly was it measuring. Was there a car in the way? If it was, then it would change the temperature data. And this is where I give it to Toby to tell us more about this new model.
Thank you, Elena. Hi, everyone. My name is Toby again. So basically, at MIT, part of the things we've discovered in the previous data was that it was 1 by 1 pixel. And then we moved to a better frame, which is 32 by 24, which gives us 768 different temperature readings. And so far, in 2022, we've captured over 1 million data points, as you can see in the slide below. Again, city scanner device, the image by the left shows exactly how we place it strategically on the vehicle. That's the way they say it in Sweden. And again, the city scanner sensor needs to be facing towards the building so that we can measure the heat of that building. Towards the right shows how the city scanner device moves around the whole city with GPS, of course, GPS coverage. And then the deep red shows how the city scanner device actually move in that same direction, maybe 100 times or maybe 67 times. Some of the results we found, clearly the frame shows that we're beginning to get fantastic results, though we can still say if this is a vehicle or this is human. But adding some sort of mathematical model and machine learning, we can better, see the city more. So far, the next step we want to explore is that, I started with 1 by 1 pixel, which is the first image there. You can't see anything. But right now that we're exploring the 32 by 24, it's beginning to show that we can get a fantastic result if we increase the thermal sensor, which is basically the pixel of the thermal sensor. And then adding machine learning to heat, we can better see that what exactly are we seeing in this city? Is it the heat? Is it vehicle passing through the sensor? So the future step is we want to be able to come together as KTH and MIT to come up with a fantastic publication. And of course, as a scanner, we want to build more prototype. And most importantly, the citizen engagement. So we want you to be part of the citizen design, basically taking some of the data from City Scanner, and then we can engage you more. You can use the data to kind of design the city. And some people can use the data for educational purposes. And if you look at the data, you say, oh, the heat map is actually from your building or from your neighbor's building. Thank you so much again. My name is Toby Oyinlola. People call me Internet of Toby. If you have any questions, please reach out to us. Bye.